Well, Dr. Coetzee, you lead the Society's research program. We know that that is a real global effort, and as we just heard, it really is amazing, all of the changes that are happening. And this is a chance where I really sort of say what is the theme here, which is the simplicity of the research message. We are stopping MS, we are restoring function, and ending MS forever. But I do want to talk about some of the solution areas that you're looking at. Maybe you can pick out one or two that you're most excited about.
Well, thank you. So Jim didn't use the word, but I'm going to use the word. It is breathtaking what's happening in MS. Jim and I met a few years ago when I was a fellow, and I would say that if you were to ask me what's the area that I'm most excited about today, I'm excited about all of our research, but when we talk about restoring myelin and repairing the nervous system, when I started in MS, we knew that the brain could heal itself, but the idea that you could actually get to the place where there could be therapies in clinical trials in 2012 for potentially restoring myelin in the brain, that's happening. And there is actually a drug in treatment and safety trials. And so,
hey, that's a headline. Let's stop and talk about that. It is. Wouldn't you agree?
Uh-huh.
So, tell us a little bit more about that. There is a drug out there that you are looking at right now that has the possibility of being able to restore myelin. Did I understand that correctly?
You did. It's one of the companies, at one of our sponsors, Biogen Idec. They have a treatment called Lingo that they're testing. That its purpose is to really clear away the damage that's taken place in the brain and really create an environment so that nerve cells can regenerate and new myelin can be formed. Now, this is really early stuff, so it's still being tested to make sure it's safe in people. But here's the thing. Can you imagine in 2012 us talking about a treatment that is being tested in people with the possibility that Elliot can have a conversation with a person who's newly diagnosed with MS to say, here are the 8, 9, 10 immune-modifying therapies we have, and let's have a conversation about additional treatments to potentially protect the brain from damage or even restore function. I mean, that's a conversation that's worth having, and it's really going to change the future, and I'm really excited about what we can do.
I think we can safely say most of us are now excited to hear about that. Wouldn't you agree? Very excited. And that brings me back to you, Dr. Frohman, and I understand that you're also doing some collaborative research that is looking at both protecting and restoring nerves, and we seem to have a theme going here as we get back to the process of restoring. Again, what does that mean for people who are living with MS? Do we look at the possibility of not only halting the disease, but perhaps reversing it in some people?
Yeah. Well, these are very, very important comments, and I would like to underscore these critical comments that were made by Tim with respect to the possibility of seeing over the next subsequent years, whatever that number is, the evolution of a first-in-class capability to promote repair. I think what we have to recognize is that the majority of patients that come in with the first event that might have provoked them to seek medical attention, the majority of patients, if you look, already have established disease, meaning when you look at an MRI scan, for example, at a very concrete practical level, most people at the time of the first attack or exacerbation, which by the way usually is an event of optic neuritis, inflammation within the anterior visual system, or it's a partial spinal cord syndrome, by the time they come in and you look at the MRI, there is already established lesions that are not enhancing. They're old lesions. We don't know how old. But my point is to underscore Tim's comment about not just applying disease-modifying therapy that will reduce the risk of inflammation, new plaque lesions, and corresponding clinical problems, but the advent of adding a therapy that would promote myelin repair on circuits already affected.
Dr. Frohman, you won't believe this because I don't either as I look at this. Would you believe our time is up? Yeah, it's hard for me to believe that
too. See, thank you very much.
But hold on.
It's been great seeing you.
But before
no,
you
just a little joke.
But before you all race off, and we have had a chance to hear from each one of you, can you give me about 10 seconds, the next couple of folks, and just tell me what you're most excited about right now?
Personally, I'm actually most excited about the potential for repair as well and for neuroprotection. some of my work is going in that direction as well. We now have a new molecule that we're testing for its ability to promote repair. It's in the very, very early stages, preclinical phases.
What are you most excited about?
That's a common theme. So I think the big surprise for many of us in the field is how many cells there are in the brain that are capable of repair. And we are identifying what I would call brakes, like the gas pedal and the brake on a car. And a lot of those brakes are starting to be identified, and by targeting, we can release the brake and get the cells to repair more effectively.
Well, I hate to have to bring this to a close because I'm so excited, but I do want to thank all of you all so much for giving us some Oh, we do have more time. Oh, my goodness.
So I'd like
hey!
I'd like my 10 seconds.
Exactly. You get your 10 seconds back.
Right.
And thank you very 12 minutes. All right.
Before
Ignore this.
Tim
All right,
gets
I've got
his-
12 minutes.
His 10 seconds,
Okay.
what I would like to say, I am over the next 10 hours,
Yes.
but that would be pajama time. The thing that I'm most excited about is collaboration. That the fact that some of the questions that we're all really struggling with have a lot to do with bringing people together that have some common overlapping, but some highly differentiated and different skill sets. Case in point, the research that we are doing looking at the eye as a model for the brain in MS, if you could panel and test therapeutics in the vision system, which is affected so commonly, and demonstrate protection and repair, we may be far along our way to applying this to the nervous system in general. So our collaborative research here at UT Southwestern with Peter Calabrese and his group at Johns Hopkins, Laura Balser at Penn, now moved to New York University. The most powerful thing that I have seen, shock and awe, breathtaking, has been combining people who are excited, exuberant, place patients at the center of the mission. And when you collaborate, things not only get smarter, more practical, they begin to move at an accelerated rate. And it's because of the National Multiple Sclerosis Society and their willingness to recognize what is the power of collaboration. And I will tell you that it trumps competition every time. Some people in this room may.
Absolutely. Absolutely.
There will always be competition, but if you remember the Manhattan Project during World War II, it did require the assembly of people with differentiated skill sets, bases of knowledge, to solve a common problem that actually the world was dependent upon.
Yeah.
And in this case, we're talking about not just MS, but if we make progress in showing neuroprotection, neurologic circuit repair, translate that into recovery and sustenance of function, this will not just be an MS thing. This will translate to a myriad of other neurologic
That's
diseases,
absolutely true.
Parkinson's disease, Alzheimer's, ALS, and I'm not overstating the case. Collaboration is powerful. My colleagues and I have been essentially in a state of shock and awe for the 7 years we've worked on these collective projects. And by the way, Lingo 1 will likely have one of its applications in the visual system because we know optic neuritis occurs so often in MS patients, and it plays itself out pathologically in 3 to 6 months.
All right.
So if you have 10 drugs to test, prove it in 3 to 6 months.
All right, and
that
I'm
it
going to
works.
be remembering Lingo 1. That's something very important for all us to remember. Dr. Gilmore, I want to talk to you about women and MS, and we know that there are a lot more women who are affected by the disease than men. And as a result, we also see changes when women are pregnant, when they are going through hormonal changes. Could you talk to us a little bit about some of the clues that you've been able to ascertain by looking at women?
Certainly, one of the clues that has come out of some work that I've done in collaboration with Dr. Glenn Matsushima at the University of North Carolina is that female brains are a little bit better able to repair the damage that occurs, and also there are...
Take that, guys. Sorry.
And also may actually not have as much damage initially as males. We don't know exactly if that translates to humans. We do know that women are more affected by MS, or there are more women with MS. We don't really understand that, but we think it has something to do with an interaction between genes and environment and hormones.
And do you see these dramatic changes hormonally? Because I've often heard women say, I felt so much better when I was pregnant, for instance.
Yes, and during pregnancy, actually the changes start happening in the first trimester. They accumulate to be most noticeable in the third trimester. It is very dramatic. It's probably best treatment we have for MS at this point.
Get pregnant.
Right. We don't. What we don't know is whether it's only a hormonal effect. Hormones definitely are part of that story. But the fetus may also be inducing changes in the immune response and that immune balance that could be beneficial.
Well, no, that is fascinating, just hearing about that.